It's my pleasure to welcome you to this conference on digital twins for sustainable infrastructures. We will explore the benefits and perhaps the pitfalls of digital twins for the infrastructure sector and for policymakers. We have to remind us that the market of digital twins will be growing from $7 billion in 2021 to an expected $100 billion in 2030, according to Fortune Business Insights. A large range of topics are at stake when considering this important subject, including the carbon impact of using digital twins, the needs of building and infrastructures industry, the challenge on training programs to equip engineers with digital skills, or European sovereignty issues in data and digital, to name a few.
A digital twin is a faithful representation of an object, a physical system. It can also be a system of systems for more complex industrial application. And so it's a digital representation, so in the form of a numerical model. But it should be clear that it's quite different from just a 3D visualization of the object.
So for me, it's a capture, so a digital twin would be a capture of a real scene, so that can be a construction site, that can be a building, that can be a city, that could even be actually a human patient, so sometimes you also have a virtual reconstruction or representation of a patient for medical application, so that's something which is very, very general. So it's not just exactly the 3D geometry, but also what we call in computer vision the semantic of the, so what are the different parts of the real scene? So is it bricks? Is it tree? Is it roads? Not just the 3D geometry.
Digital twin, you have the digital part, so you have to come up with something that's representative of what you are dealing with. So if it's railway infrastructure, you have to come up with a representation of all the components that would make a railway infrastructure. And you have the idea that all the objects are somehow linked together within this digital twin.
It's a model, and a model is something that should be logical and useful. I mean, a model could be something very simple but very useful. For example, like the law of gravity for Newton. It's very important to understand that because it will drive how we will do digital twins. We have to define the use case. We need to explore with the digital twins, and we can design the model concerning these use cases. For example, we need to repair the roads, the pavement very often. If we understand more the pavement and how the vehicles on the pavement is working, we can define new strategy to replace it. And I mean, in an ecological world, it's very important to work on that because if we can use our pavements 1, 2, or 3 years more, I mean it's less energy at the end used to replace it, and less materials.
So I think the word has been introduced in the early 2000s by a professor from University of Michigan in the manufacturing sector. So the idea was to better represent industrial processes, to build objects, etc. But in fact, the concept, I think we can trace it back to the early 60s with NASA, who first, so it was not a digital twin, but a physical twin. And obviously, since then, there are some industries that have used and developed these concepts earlier than others. I think right now the aerospatial and aeronautics industry are really at the top level. The naval construction also, when you build a nuclear submarine, you can imagine that is extremely complex and that you want to have an accurate numerical model. Formula One also really always at the forefront of technology. So in this case, it's useful for both development, design, to test performance of the object.
One is about security. When you are running trains on rails, you need to be sure that there will be no incident. So you have to detect obstacles, right? So you have to do what's called gauging. So you have to make sure that there's nothing that would stop the train from running. So doing that, you need to have a very precise measurement of where the rails are exactly. So that's a first instance when you need a lot of detail to be able to do that measurement.
In the case of a city, so if you know the material of your roads, where you have parks or trees, then you can simulate. So that's once you have this digital twin of the city, then you can start simulations of how the flow of cars are going to change or to move, or how the temperature is going to evolve with the climate, and then you can start planning how you can change your model. Once you have the simulation, that's something which is very convenient. You can try things on your digital twin instead of trying directly on the real city, on the real thing. You can try different solutions, different aspects, and then you can take a decision. So that's one of the general application of digital twin. So planning or monitoring, definitely.
Vegetation is hazardous for the train circulation, but managing the vegetation is something that needs to be done wisely, and you need data to be sure where you need to cut, where you need to manage, and how you need to manage the vegetation. So having more information and more ways to do more accurate actions. It means savings in energy you would waste otherwise doing things that are not maybe as accurate as it would be thanks to digital twin that would give you insight. And you can have also specific trains with more sensors, more systems that could acquire data and run the tracks, every day, and to cover all the infrastructures. You can have also information from the sky using planes or helicopters or even drones.
The question is how to make the data reliable. Because the digital twins represent the reality, and the reality is not static. So we have to design something that is dynamic, and all the guys that are working on the real infrastructures that they make changes. Sometimes it's some maintenance, sometimes it's when they can replace some equipment, something like that. So we have to make them contributors of the digital twin.
So it's not just a matter of collecting the data, you have to transform the data into something that is useful. And that's really, I think, for me, that's really, at least in terms of the kind of things I do, that's really the core challenge, to transform these data, so these raw images captured by cameras or maybe other sensors, in fact, into something that is useful. So interpreting these data, that can be quite a lot of data, but it's not just a matter of volume. So really understanding what we are looking at into something useful. So in the case of I don't know, for the rail, so where are the vegetations close to the rain? What is the shape of a bridge? For this, you need to analyze the data, and for each field, you probably need different techniques.
The main challenge is to is that this data, it really questions all the process inside the company, and I think, like Baptiste said, it's really important that there's a digital transformation inside the company to be able to tackle this question of data at all the levels, because there are some questions on acquisition, some questions on processing and analyzing the data, and at some point I think the main goal of digital twin is to make data-informed decisions.
Digital twins bring a lot of opportunities. It also brings a new perspective for digital transformation of the different sectors, companies, and also impacting society. So École des Ponts has launched also with some partners at EELISA European University this new master. Jérémy, could you tell us a little bit of what is in stake here with this new program?
It's a program which has been funded by the European Digital Program for 4 years. So basically we have 1 year to develop a master program for engineers, and then 3 years to deliver it. And at the same time, we will also develop a center of excellence, which will try to create a network of academic industrial partners on these questions to gather best practice, foster new projects, and accelerate the development of startups. So the partners are members of EELISA, so we've mentioned UPM Madrid, École des Ponts, BME Budapest, Istanbul Technical University, and the University of Bucharest, with also 4 SMEs. So there are 3 companies in Spain, which are Nomon, Tyrus AI, and Main Rail, and we also have Altametris, who is part of the project.
So in terms of, we should probably put more emphasis now to data science, artificial intelligence, so that's which is something not necessarily natural for civil engineering, for example, but the importance of IT, but really specialized IT, data science. So we mentioned that data capture, data analysis is the main challenge, and that's something, yeah, so the future engineers need to understand. So it can be difficult to understand, to have a good intuition of what is possible with AI and what is still challenging. So they need to be trained for that. Maybe they are not going to develop directly the techniques, maybe they will, but at least they need to understand that.
You bring into the digital twin a lot of topics, and you can't have just a collection of experts. You need experts because you need it needs to work, but you need to have people that can make it real. So you need to have people that can apprehend all the main issues, all the main challenges.
We will need to be more clever and to collect more information to prepare more our intervention, our building infrastructure. And the second point is that all the infrastructures that we have inherited have been made by guys that are retired today. They are not there to explain how it works. So we have a specific mission, is to collect this information, be sure that all this information are reliable and are shared with other guys to ensure that the infrastructures will live longer than the guys that are managing there today.